Okay, so we'll start in 1 minute. Thank you.
Oh, do you still have slideshow?
Yes, now you have to put it in a slideshow, sorry.
Yeah, okay.
There it is. Okay, so thank you everybody for joining today's webinar. Welcome to this ISFE webinar entitled Global Challenges and the Critical Needs of Food Science and Technology by Dr. Peter Lillford. Briefly, Peter graduated from King's College London with a PhD in physical chemistry. After a postdoctoral position at Cornell University in New York and the San Francisco Medical Center, he joined Unilever Research. He worked as research scientist in Unilever, and he covered a lot of products range in this company, including meat and fish, bakery products, margarine and dressings, ice cream, and even toothpaste, lipsticks, and skin creams. He was awarded the Senior Medal for Food Science by the Royal Society of Food Chemistry and an Outstanding Achievement Award by the European Federation of Food Science and Technology. He was chairman of the UK Technology Foresight Programme and Food and Drinks, and awarded a CBE for services to science and the food industry. He retired from Unilever as chief scientist in 2001, but continued research and held McMaster and flagship fellowships with CSIRO in Australia. For 10 years, he chaired the board of the Institute of Food Research in the UK, and he is now a visiting professor in the School of Engineering in Birmingham University and consults for several multinational food companies. Now, before we start, please remember to mute your microphone during the presentation, and if you have any questions through it, you can either write them on the chat so that you do not forget them, and at the end, you can ask them directly to our speaker, or if you want, I can also read them aloud for you. Thank you all for being here with us, and welcome, Dr. Peter. It is a pleasure to have you as speaker. Now you have your audience. Thanks.
Thank you very much. Good afternoon, ladies and gentlemen. I'm very privileged to be addressing you all this afternoon. So let us begin. My main challenge this afternoon is to make you realize just how important you all are. We start with this first slide, which is the basis of what I'm going to talk about, because IUFOST were rather concerned about the future status of food science and technology worldwide. In particular, we noticed in Europe and up to a point in North America that the amount and the quality of food science and technology research and innovation was declining. And we didn't know why, and so we set about correcting that. So we start some 5 years ago, and we'll start where my colleague Dr. Anne-Marie Hermansen and I started when we tried to put this story together. And essentially, I can't advance the slides.
You wanna get out and then get in?
How do I do that? I'm very...
Escape?
No, it's locked. Oh, I don't believe this.
Don't worry.
I have to stop sharing.
Yeah.
And I have to share again. Reload. It worked a few minutes ago. We checked it.
Yes, don't worry.
Yes,
there it is.
We're back in action. Very sorry about that, folks. Just to recap, I'm going to start where myself and Dr. Manson started when we tried to put this story together. The sustainability goals, global sustainability goals, had recently been published, and we thought, well, we must be able to find the food supply chain in here. And sure enough, let's go through it. And you'll be amazed, I think, by what you see. No poverty. Well, I can't say that we'll reduce total world poverty by doing food science and technology, but zero hunger, definitely yes. Good health and well-being, part of our job. Education, absolutely vital. Gender equality is an interesting one. We didn't make too much store by this, but I've since been reminded that in most of the world, the food chain and supply of food to families and so on is determined largely by women. It is not a male-dominated supply chain. If we keep going, affordability and clean energy, well, that's a major effector of the food chain, as we'll see shortly. Decent work and economic growth, absolutely. Even in the UK, the food manufacturing business is the single largest manufacturing business in the UK. Industry, innovation and infrastructure, part of our job. Reduced inequalities, well, we hope so. Sustainability and community benefit, what would it be without a reliable and sustainable supply of food? Climate action, definitely. Our raw material is wholly dependent, by and large, on the vagaries of the climate. All of our materials are naturally derived. Life below water, well, we'd be short of an awful lot of fishing food if we let that go unsustainable. Life on land is clearly a lot of our responsibility. Peace and justice and partnership for the globe, well, we all hope for that. But you will see that the food chain is integral to some, I think, 11 of the 17 sustainability goals. So what the world is saying, even at the political level, is without us, the world's in deep trouble. But our job is to make our industry sustainable, which, as you will know, in some cases, it certainly is not at the moment. This is a slide you'll see, which was published in Europe, explaining the links between society and the food chain. So it's a circular diagram. We start, say, with agriculture, which derives income and employment, from which comes health and nutrition, and certainly markets, including insurance. But where's science and technology? Well, look in the middle. Safety, availability, access, diversity, and efficiency. Most of what is required to achieve any and all of those objectives is food, science, and technology. So we're right in the middle and crucial to the future health and well-being of the food chain. Yet again, this document mentioned in passing that food processing and manufacturing was quite important. Now, I must say, this enraged myself and Dr. Manson, and this is where we set about correcting that and getting the challenges and missions statements for food science and technology and pulling them together for our UFOS. So let's take a look at the food chain. This is familiar to all of you. Raw materials primary production comes from farming and fishing, but now the chain is enormously diverse and complex. Some of it goes straight to the fresh chain to the consumer and you just eat it, but not very much. About the only things that do that are fresh fruit. A lot of the rest has to be manufactured, processed, and uses ingredients to do so. Now, there's been a lot of controversy about the use of ingredients and their naturalness. That's justifiable because we have to admit in the industry that if we could find a nice chemical that made all of our processes stable, like a very good emulsifier, for example, we'd use it if we could, for cost savings reasons. But what that has done is produce foods with names on labels that people really can't understand. And so the E number, instead of being a safety guidance code, has become an artificial ingredients code. Some of that is justified, some of it is not. But I will remind you that if you think about anybody's daily life, whether your food comes from a factory, a wholesaler, a retailer, whatever, or you make it yourself at home, it has to be processed. There's an awful lot of food which is simply inedible without processing. I leave you all in a field of wheat in the height of summer. With the best will in the world, you'll find it difficult to feed yourself. Despite the fact there are calories all around you, you'll get pretty fed up with chewing grains of wheat. Then comes the distribution arm, catering and retail. We, in the developed world, go out to eat an awful lot now, or we use takeout systems, all of which we've included in catering. And then the retail, of course, is anything from the shop on the corner to the great big supermarket chain like Walmart's or whatever the equivalent is in your world. The consumer sits at the end of it, in many cases blissfully unaware of what goes on further up the supply chain. In a recent study, in English schools, under 10s were asked where eggs came from. They said basically, well, from the supermarket. Yeah, but where do they come from before that? We don't know. So we are becoming increasingly detached from the primary production and the conversion process of our foods, which is in itself dangerous. Yet the consumer in recent years has become increasingly aware that their health is entirely dependent, well, not entirely, but significantly dependent on what they eat. And the processes we are using to produce their food are damaging the environment in terms of the energy we use, fertilizer runoff, and so on. So we are in a bit of a critical storm where the consumer is concerned but doesn't understand the chain, and the chain is desperately trying to keep itself alive. Now, what I'm going to focus on this afternoon is actually the bit in the middle. It's not that I don't think farmers are valuable, they're absolutely valuable, but the basic sciences of food science and technology have tended to be focused on the conversion of primary products to ingredients, their manufacturing into finished products, or the safety and distribution of all of those things. So the hard-nosed, invisible food chain is that bit that remains there. Clearly, we know about the consumer at the end because they determine whether we sell anything or not. But if you look at the positioning of the industries that sit in that box, they're in the private sector, by and large. So governments can talk a lot about the food chain, they can legislate around it, but they cannot control it. It has to be a partnership between those who have the science and technology to perform the conversion of primary produce with the consumers at the end who hopefully are represented by their political masters, certainly in a democratic society. And what was missing, we felt, was any understanding of what actually went on in this part of the chain and the skills it would need in the future, with the warning that things are not going to be the same. We've talked about global change. This presentation was put together as a futuristic presentation. None of us considered the possibility of a global pandemic or a serious European war. And because of those two, and certainly in the UK, because of the political matters, our current food inflation is running between 13 and 26%. One of the staple English snacks are potato crisps. Believe it or not, the UK is running out of potatoes. This is something that nobody could possibly envisage even 3 or 4 years ago. But it's happening. We are now at supermarket shelves, and we have rationing in the UK in fresh fruit like tomatoes and cucumber, because we can't grow them, and it snowed in Morocco. Now, that is clearly something to do with climate change. So in the developed world that I live in, we have seen, and our children have seen, for the first time ever, food rationing. You can only buy 2 cucumbers, no more, in a shop in England at the moment. So the effects and the changes are real. So we better take these things seriously, because without the management and the expertise in operating this part of the food chain, we're going to be in serious trouble, not only in the developing world, but even in the developed world. Now, what is this industry then, and what is it all about? I'm sure many of you have worked within the food industry, and particularly the food manufacturing conversion industry. And we talk bravely about our science of biomaterial science, our understanding of rheology, process engineering, and structural sciences. And inside all of these, we have this loose term called food quality. But let's be honest for a minute. And how much food did rheology, science, process, and structure ever really create? It was said once within Unilever that we only ever invented one novel food, and that was when we took the bones out of fish and put a battered coating on them and called it a fish finger. Most of the foods we eat were traditionally developed, geographically resourced, and what this industry has tended to do up until about 10 years ago was simply upscale it. The engineers did an absolutely wonderful job of making factories from kitchens. When I first joined Unilever, we had the largest soup company in England. We also had the largest saucepan in England, because basically what did we do? We copied foods and upscaled kitchen processes with good engineering basis. But that's not going to work anymore, because the supply of the ingredients we're so used to having is at risk. You know, we've run out of potatoes in the UK. It's ridiculous, but not too surprising. And the other thing is that's going to happen across the world because primarily of climate change. We're going to have to accept in this skill of ours the need to understand materials so that we can design and build sustainable and efficient processes rather than just copy and upscale what housewives did 100 years ago. So on the basis of this, this is a very busy chart, I do apologize, but it simply attempts to introduce what I'm going to talk about in more detail. We said we need some missions. The thing about a mission is you've got to do something to achieve it. We didn't want to make general statements anymore about climate change, sustainability, energy and water. We needed to do something, and that requires a mission, and a mission has a start and an end and something you do in the middle. So this is just to simply on the left, the missions, which we'll discuss in more detail, but the key drivers, which mean that they are necessary. So I'll leave that with you. I mean, most people could have drawn this chart for themselves, but I just wanted to advise you that we wanted not to just make general statements, but give ourselves a job and explain to our customers, our farmers, our politicians, and so on, why we need to do all this for the sustainability of our food chain and therefore the health and well-being of humanity at large. So those are the 6 missions, and we're going to go through them now in some detail, just to explain what we think needs to be done. Now, these are still recommendations. Obviously, we can't do it all. But I must say, in speaking to people, there's increasingly awareness that this really must be done, because we're going to face a change in raw materials basic supply, and we cannot go on burning energy in the food chain the way we used to. And certainly in the Western world, we can't stay throwing it away, the finished products away, as we frequently do. So off we go then. Let's look at the missions. Here's the first one: to introduce more diverse and sustainable primary production. The challenges for food science technology will be to test how they function. I'll give you an example. Starch. Starch is starch. We know it's a raw material. It's a really very simple one, isn't it? But if you try and you have a process critically dependent and developed for the functions of cornstarch, and you run out, you're in trouble, because your processes won't work if you try to use rice starch or potato starch. We have so refined and optimized our food processes, they're not flexible anymore. And in many cases, I'm sorry to say, we don't know why. Because starch is not a simple raw material at all. It's a highly complex array of partially crystalline materials of polysaccharide origin. Now, there's lots of literature, I agree. You try and link all that up and predict what would happen if you took cornstarch out of your products and put some other starch in. So first of all, we have to be able to test the functions of the ingredients we're using, and then understand the behavior of things when we put them together in our conversion operations. And this is all about kinetics and temperature and lifetime and residence time, things engineers love talking about. But then they come to the material science and say, well, we kept all of our bit the same. Why doesn't your starch work? And the answer is because we never understood it, and you set your processes to control the starch you had to begin with. It's not generally understood. But what do we think is going to happen? I mean, I've given a few examples. Amaranth. Now, this is a crop we're totally unfamiliar with in the UK, but it makes leaves from which you can get protein, and it produces excellent yields of starch, and it's drought tolerant. I once gave this lecture in Buenos Aires, and the people from Mexico said, amaranth? Of course we know about amaranth. What are you talking about? We know how to use it. And we say, oh, really? Oh, good, because we don't. So the rest of there's information that we are not properly transferring to each other. The other thing that's developing, of course, is the need for vegetable proteins. It is really true that in terms of land use, animals are not as efficient as plants are in producing protein. So now all of us are suddenly becoming aware that we have to be more vegetarian or vegan. And the problem in the UK is, where do we get our lentils from? We don't know what they are. People use them, and again, they're a highly sourced material, known very well in parts of the world, in India particularly, for their high protein levels. You try and make a meat analog out of them, though, and you're struggling. We can just about make a decent sausage or something like that. But the basic architecture of meat is not present in a lentil, so you have to create it. Now, you could say, well, people should just stop eating meat and eat lentil soup instead, but they won't. One thing we've learned about consumers is that they have traditional likings, and they don't like being told what to eat. They don't mind being told to eat a bit less meat and a bit more vegetable protein, but to be told that they can never have this architecture, taste, and texture that they're familiar with meat is not going to work for an awful lot of people. So we have to learn. The sources of materials are there. They're widely used in parts of the world, but the information and knowledge of their science and technology is not widely spread. That's got to change. That means we need to talk to each other an awful lot more. Moving on then, new processes and systems. Now, this is really the responsibility primarily of the manufacturing industry. We use far too much water and heat and pour it down the drain. The interesting thing is when we talk to other manufacturing industries, they say, well, you know, you don't need to do that much. When you tell them, however, that every bit of plant you have to use has to be cleaned once every 36 hours, otherwise your product becomes contaminated and could kill somebody, so you would go to jail, they change their mind a bit. We have a unique industry using unique materials, and uniquely people put them in their mouths, and they're very conscious, and so is the law about what goes in your mouth. It has to be safe. If it isn't, you go to jail. So we have to be very careful, and we are, but what that means is our processes can be quite wasteful in heat and water. Minimum damage to react. Now, here's where we start talking to nutritionists who say, well, it's all very well, you process these foods, but you've knocked out all the micronutrients. Oh, very sorry, didn't mean to. But, you know, sorry, but vitamin C is not heat stable. We have to cook it because otherwise you can't eat it. So there is a need to look again at the degree to which we process things. And in many cases, we over-process for the sake of safety. It's not always necessary. What's even better is there are already existing processes which leave the micronutrients largely alone or even add benefit. These are called fermentation. These are traditional processes throughout the world, again, which we don't share properly. So we know that fermentive organisms produce a whole battery of enzymes. And so basically the nice thing about enzymes, they're catalysts, so they run processes at lower heat and moisture usage. That's what a catalyst does. So there is going to be, and I'm pleased to see there is, great amount of work being sponsored now in modern, efficient, large-scale conversion by enzymic and fermentation routes. And the other thing we do is we preserve our food. Well, how do you preserve it? Well, you can freeze it, you can dry it, you pasteurize it, you can sterilize it. The majority of the world dries its food. And if you can do that with natural sunlight, it's very cost effective. And wherever we operate in hotter countries, Unilever tends to make dry material. The problem is not drying the food or the ingredient, it's rehydrating it, because there are sensitive biological materials. You dry them down to a low relative humidity or moisture content, and they say, that's it, I am sand. You add water and they don't do anything. It's a major issue, which has been quite widely studied, but we still can't solve the problem. Anybody who can make me a nicely rehydratable mushroom piece will make a fortune, believe me. There are some ingredients that are so structurally complex, when you dry them down, you don't get them back again. Certainly not at the moment anyway. So here are the challenges to process engineers. How are we going to do it? Don't know, but so that's the challenge. Moving on again. Oh, no, I've got just some examples to remind you what I'm talking about. Fermentation, well, we all know there are fermented foods and drinks. What would the Englishman do without his beer on the left? Largely made now by Germans, I must say, but I mean, it's, or even the Danes. But I mean, this is part of our lifestyle. To tell an Englishman that he's never going to drink beer again, there would be riots on the streets. Bread is there as well. and a staple diet for majority of people around the world. On the right, however, I think that is kimchi, or some of it is anyway, and this has incredibly efficient maintenance of micronutrients in the raw materials. Kimchi? Never heard of it in the UK. I had to go to Japan once, and by the time I'd lived there for a fortnight, I was absolutely hooked. It's very nice if it's prepared well, and these old customs can be transferred between consumers around the world because they're nice to eat. So we're going to see more and more transfer of traditional technologies around the globe. But to do that, we'll need the scientists and technologists who understand how they work to assist in the transfer. It isn't just a question of going to a chef and saying, make me something nice. I don't know about your country, but there are more television programs with chefs making something nice than anything else. But if you actually go to their restaurants, you'll discover why manufactured foods are absolutely necessary, because you can afford to go about once a month. After that, you have to take out a bank loan. So it's not the future, just asking chefs. They can give you good ideas, but I mean, it is the science skills, kitchen skills to a larger scale that is absolutely necessary. Right, let's move on from the process engineering part to the manufacturing. This is the bit where you take something from a farmer's field and you end up in a supermarket. So traditionally, we have tended to centralize manufacture. Why? Because the engineers know that the bigger, the better, the more efficient. So the reason why we've got centralized manufacture, particularly in the developed world, is for efficiency. And I must also say, because there's more profit if you do it that way. And don't forget, this is the private sector. We are there to make a profit. Without that, we'd go bust and we wouldn't be there anymore. Now, the problem with this is costs of energy and shipping. Previously, and certainly when I started working for Unilever, you didn't worry too much about the shipping costs. Energy was relatively cheap. You could get an awful lot on a boat and ship it even from Mexico to Europe. It wasn't that expensive. But now that's not the case. There's a tipping point at which the global supply chain, where you have large globally centralized centers of ingredient manufacture and so on, isn't economically viable, let alone sustainably suitable, because it just isn't going to work anymore. And our modern food industry is built in the recent past, since the Second World War almost, on the basis that energy is cheap. And energy certainly isn't cheap now, and it almost certainly is never going to be again. So we're probably going to have to think about scaling down, not scaling up. But we need to get the same efficiency. And every engineer will tell you, the bigger the plant, the more efficient it is. Not good enough. We're going to have to downscale without the loss of efficiency. That means we're going to have to be very much more clever about every operation, including shipping, packaging, distribution, and all of that, if our food is going to be sustainably priced. The other thing is, everybody wants to do life cycle analysis now. So everybody will show you that my product is, I've done the life cycle analysis and look how good it is. The problem with that is it's not always true. There are really no harmonized metrics for sustainability measurement globally. And unfortunately, What that means is, depending on which system you use, you can prove that almost anything is sustainable simply by missing bits out. So there's a real plea here, not for food scientists and technologies to do the harmonization. That will be a matter of law and politics. But to provide them with the best rules for harmonization and the best science and engineering for harmonization is our job. We have to do it. Who else can? No one. So a big challenge, where we have to work closely with legislators. Here's an example. I thought you'd like this, downscaling. This is the dairy industry in Dubai. Whoever thought of milking a camel? Well, obviously the Arabs did, but now this has become a national industry, works in the desert. Camel's a pretty good animal. And on the right, you'll see some very sophisticated cheeses, which you can buy in the best shops in London at enormous prices. So here's a case where the technology of the cheese production is the same as it was from cow's milk and whatever, but it's been downscaled, made suitable for a different animal altogether, and produces a different kind of cheese, which very cleverly has been marketed as a specialty food. So the innovation can really be very clever. And I have absolutely nothing against this. I wish I'd thought of it myself, because it provides two things. It provides milk to raise children in Arab countries, and it provides sophisticated cheeses for the rich to buy in Harrods in London. What a good idea. But they've used all the developed technology and applied it to their own situation with some great success. Congratulations. Wish I'd thought of it. Okay, we're moving on now to the downstream of distribution, but we're going to talk about, no, sorry, not quite right. We're going to talk about waste throughout distribution now. Now, where does waste occur? And the answer is everywhere. In production, because it rained, so you couldn't harvest your wheat this year, and it rotted in the ground. That happened in some countries in Europe. Distribution, well, apart from the fact that lorries get stuck in traffic jams, ships now get stuck just south of Ukraine, which means the majority of North Africa and part of the northern Europe are short of wheat and potatoes. That is a real fact. And who would predict that this would have happened 2 years ago? But the problem is this has been induced by a war, but anything that disrupts the chain is going to cause these sorts of crises. So we need to improve the storage and stability of primary products, the chill and frozen distribution, but without the high energy of the past. So solar energy, other forms of heat and power, why not? Why don't we do it? It's because we never had to. Now, engineers are beginning to do that. We are beginning to see solar-powered dryers and solar-powered refrigerators, believe it or not. It's called a reverse heat pump, actually, and you can use the heat anyway. It didn't occur because necessity now is the mother of invention in some of these areas, and that's for a good thing. But we will still need highly professional engineers and food material scientists to make these things work. Again, the same applies here. Sensors, look, we need to be able to measure what we've made. We haven't necessarily got all the right sensors. Restructure the ingredient food assembly into a side stream. The oil industry has done this for generations. They call it a refinery. You don't have a petrol factory, like a chicken factory or a crisp factory, you have a refinery, because they know that practically every fraction of what they get out of the ground is valuable and has to be used. We have to take exactly the same attitude to farming. They are the producers of highly valued materials, which will need to be fractionated, but never throw anything away. The other thing is, because our food is perishable, we necessarily have to package it more carefully than most other industries. And how have we done that? Thank God for plastic. Water impermeable, oxygen impermeable. You can do modified. It was God's gift to the food industry, plastic. But you know the problem now. It's one of the world's major pollutants. We can't go on like this anymore. The actual amount of petrochemical materials used in packaging is quite small, but the environmental consequences of them being so stable is disastrous. So what we've got to do is develop recyclable, bio-based materials. And we're beginning to do it. Why didn't we do it before? We didn't need to. Didn't know there was a problem. Sorry for all the fish. Sorry for all the particles. Didn't mean to. It was environmentalists who said, you've got to stop this. You're polluting water, killing fish. It will be done, but this is high science. This is the same quality research that was done when the plastics industry was developed in the last century and before. We're starting all over again. So again, just a few examples. This is the horror story for the developed world. This is waste on the left, on the y-axis versus GDP. So you see on the bottom left, sub-Saharan Africa, very low GDP, very poor country. What is their waste? Practically nothing. You don't waste much if you're starving. And what happens is there's two bands there. The orange one is the highest, the richest people in those countries, and the blue one at the bottom is the poorest people in those countries. And what you see is that as the rich people go up, the waste goes up. So we're throwing food away because it was cheap. Now, we said 20 years ago, well, there's a simple rule for that. We just put the prices up. People won't throw it away then. That is absolutely indefensible if you're working in the private sector. Your job is to produce high quality food at a reasonable cost. So that was an unsatisfactory answer. Now we see, particularly because of the pandemic and so on, that the commodity prices are rising very rapidly. And we're beginning to realize we really can't afford to throw it away, even the richest people. But that is a societal issue, not just an issue for the food chain itself, but because of our necessary need for packaging and controlled packaging, we have to do something about it. So I think, oh no, sorry, I missed a bit out. Here is a sugar refinery. Now, why we've had sugar refineries before. We didn't have chicken refineries though. Why do we have sugar refineries? Well, in the UK, we get our sugar from beet. That means we need fuel, tractors, seeds and plants and whatever. What comes out the bottom originally, in the bottom center, you see, is sugar. That's why we did it. But because of the pressure on the costs of electricity and fuel, 20 years ago, the sugar beet industry said, we've got to add value to all of our byproducts. Now, what comes off the farm is a sugar beet, which is a big thing, covered in stones, grit, or earth, and so on. They wash it. They now sell the topsoil. The stones they bag up and sell it to garden centres for people to decorate their gardens. The pulp press goes to animal feeds, as does some of the lime, then comes the sugar. But look at the other things that they now produce. betaine, very highly valued raw material, bioethanol, good stuff, and tomatoes. Now, why should a sugar beet factory produce tomatoes? And the answer is because there's a lot of waste heat. So they can afford to heat the greenhouses to grow the tomatoes. Now, this is biorefinery in action. This slide was given to me by a friend in the UK, and we said, well, you know, why did you do all this? And his comment is at the bottom, because as an industry, we would have died if we didn't. So necessity is the mother of invention. This is going to have to come to practically every food processing factory wherever you find it. They're going to become biorefineries. How are they going to manage it? How are they going to run it? Scientists and engineers, food scientists and engineers. If you take an aerospace engineer and ask him to run a sugar beet refinery, he makes quite a mess of it very quickly because the rules are not the same. So it's got to be specialty science and technology. Going on to packaging, I like to show you this. Heinz have now launched a paper bottle of tomato ketchup, certainly in the UK. This bottle is made of paper and it's been made impermeable enough that it lasts the lifetime of a bottle of tomato ketchup, which isn't very long actually. You get through, in England, we get through a lot of this stuff quite quickly. This bottle is recyclable, made of paper, no plastic in it, except the top. And they're working on replacing the top. So again, it is possible, but I'm working with a company that is doing this. And believe me, the engineering in this thing is pretty ferocious. And what you have to understand is, what are the properties of tomato ketchup that you have to maintain so it doesn't leak through the bottle wall? So you have to have both food science, technology, and engineering, even to make the new packaging material. Product safety and traceability. As I said earlier in the talk, this is mandatory for us in foods. We make foods that kill people, you go to jail. But it's not easy because we're constantly fighting against other things that like eating our food as well, called microbes. So the majority of the food industry is dominated by safety and antimicrobial and now antiviral safety. Unfortunately, we've tended to do this with antibiotics, both in the primary chain and in cleaning factories. And now we see that microorganisms have developed resistance to many of the things. And you see these antimicrobial resistance events occurring more and more often, both in the home, in hospitals, in farms, and in factories. This is going to be a big problem where we have to work with veterinarians and medical microbiologists, and that's what we're doing. And finally, if you're going to keep something safe, you better know where it came from. And this is traceability, which is a job for, by and large, IT. We'll come back to that in a moment. Just to give you some examples, there's great hope for this. We can make new antimicrobials. Some of you out there may well be geneticists and genetic engineers. It is perfectly possible now to design new antimicrobials to work against the new. Now, whether these should be introduced widely is another matter. They're certainly not allowed. But food scientists are going to have to work with biologists and genetic engineers to understand the safety of our future food chain. It's inevitable. Finally, let's make people healthy. Well, without food, they'd be pretty unhealthy. Starvation is not a good health state. So our industry, primarily simply by providing food, keeps the majority of the world's population healthy or alive. The reason for the burgeoning population is not just medicine, it's the food chain, which is advanced dramatically in terms of its capability of feeding people throughout the world in the last 30 years. But there's this divergence between rich and poor. So the food that we eat in the West, which is relatively cheap to us, is impossibly expensive for many parts of the world. Now you could say, but this is a political issue. It's nothing to do with us. Well, all right, let the politicians solve it then. How do they do that? What we want, and this is exactly what happened in the UK, what our nutritionist said, what we want is to feed the poor just as well as the rich. How are you going to do that then? Well, somebody should do it. Well, who? It has to be the food chain. The food chain is dominated in science and technology by private sector industry. It needs then to be co-founded with governments who are responsible for health and well-being, because otherwise it'll just go to the profit motive. There is a bit of a war afoot now between politicians and the food industry, because you should be feeding the poor, and also you should be giving your shareholders profits. The two need to be balanced. And that is a necessary dialogue, which unfortunately, in many parts of the world, is breaking down, not getting better. So this is but the fact of the matter is, I've never seen a politician who could make a cheap food. He usually would ask his wife to do it at home. This is not an issue to be taken lightly, but it's absolutely necessary. And to do that, we'll have to begin to use local crops, because one of the ways of saving money is to stop refining and shipping things all around the world. Use it locally, cut the distribution costs, make the manufacturing efficient, which is what the camel drivers in Dubai did. So we know that there are solutions, but you're going to need the local science and technologists to do it. It won't happen because politicians dictate. It takes science and technology. Oh, there's some examples I use just to show to people the gaps in world economics. On the left is Sudan, 2014. I hope you can read it. This is children less than 5 years, 40% stunting, 31% underweight, overweight 5%. In the United Kingdom, in 1979, which was 40 years earlier, stunting and wasting had almost been eliminated altogether. It can be done by the appropriate provision of foods at a reasonable cost to the population it serves. That has to be the solution. The food must be supplied to in the regions to the populations it needs to supply. So downscaling and localization of efficient food chains is going to be absolutely necessary to ever solve any of these problems. Now, health is really a tricky one, because now we have to start talking to doctors and biologists. This isn't engineers and physical scientists anymore. This is hard stuff. But as you know, there is a revolution taking place in medical science, and they have all sorts of techniques to tell us about how people's bodies work, subject to what they put in their mouths. So we can look at genotype mapping, metabolite mapping, nutrient needs for individual nutritional groups, precise advice on diets. Here's where we need vitally to collaborate, because doctors and nutritionists will say, if necessary, you should eat this. You should eat something else. What that implies is an enormous diversity of materials and availabilities in terms of diets. That could be done, but at the moment, the trend is to simplify product ranges not diversify them. Now, a diet is made up of several different foodstuffs. Each of those might need to be tailored. This is a phenomenal job, and quite contrary to what we thought we might have to do 20, 30 years ago. Not only that, you've seen developing the nutraceutical, the wonder food, in many cases based on some reasonable evidence, but not much. And so, again, we need to help the medical scientists check that this is going to work properly. Now, the food industry is the one that is used to using cohorts of consumers. The only other industry that does that is doctors in clinical trials of medicines. We're going to have to start doing, and it's already happening, clinical trials of nutraceuticals and so on. And in which case, when we find benefits, who's going to produce the food with the benefit in it? The job will fall once again on the food manufacturer and an ingredient supplier. We've got to learn all the new biology, or at least collaborate. But it's great fun, this. I mean, here's some examples I'll give you. This is a paper in Trends in Analytical Chemistry, which set out, I read it if you can, because it sets out how all these things can be linked together. So it's a review of how the technologies and sciences that we already have can be used to join all this knowledge together. But it's phenomenally expensive, and it won't. We should do this. There have to be plans for collaboration to do it. Now, fortunately, there are, and so we can look for a bright future. But what it means is the food scientists, technologists are going to be very busy, very, very busy. And I'm worried, certainly in my part of the world, there aren't going to be enough of us left because it's a dying trade. Oh, and here's the nicest one. I was engaged with some work on nuclear magnetic resonance imaging. It's one of my earlier branches of science. And this is the effect of sugar on the brain. Notice that it's not very different from cocaine. The nice thing is, fortunately, that sugar is not as ridiculously addictive as cocaine is, but the pleasure is similar. Those are the pleasure centers lighting up on both. So people say they're addicted to sugar, yeah, but not as bad as cocaine. But we can actually study what metabolites do to the way we think and the way we feel now. Brilliant, fantastic stuff. Oh yes, here's obesity. There was a study in the UK, no, not in the UK, of whether it was something to do with the brain, the tendency for some people to become obese and others not. And what they found in this rather limited study, but very interesting, is that obesity is associated with lower opioid receptors, but the dopamine receptors remain similar. So in other words, you can't stop. So it's signaling in the brain of your inability to stop eating because it's nice. So there you go. Very early study, and I wouldn't say that's conclusive evidence. It just shows what can be done now in terms of food and ingestion studies. Finally, then, the last mission. This is big tech, what everybody now calls technology, which offends me. There's other technology than digital, but here it comes. This is computers. And certainly they offer enormous opportunities to the engineer, the nutritionist, and the distributors and the food chain controllers. Let me go straight to examples of what I mean. I thought you'd like this. We can now write down the mathematics of popcorn. Here is the equation for the accelerating probability that a popcorn will pop. The only problem is it relies on certain inputs, which are the size of the popcorn, the size of the pericarp. So, but all popcorns are different, as every food scientist knows. So by and large, the mathematical modeling in the food processing industry tells you about the directions of change and the important parameters to consider. It very rarely tells you how to run your factory, and it probably never will, simply because the raw material is variable. So wheat one year is different from wheat the next. We're always going to have to optimize. But at least this kind of modeling allows you to diagnose the most important things you need to control. Here's another one. Everybody's heard of blockchain. We now with computers can, this is actually a Mexican pig farmer who is going to sell his pork meat to the English. This is a case study. With digital blockchain systems, you can track the material throughout the world, minimize the prices, organize the contracts. It's a very, very efficient way of running a business. The problem is, however, who controls the quality and where? And the answer is it has to be everywhere. Because what happens is, if you can track everything, if something goes wrong, whose fault is it? Everybody says, not me, boss. Mine, it was all right when he left my farm. It was all right when he left my factory. Then there is a constant need in these days of, this is a very efficient way of running a food industry, blockchain. I've got nothing against it. But it's got to be monitored and quality controlled and safe. And there again, food scientists and technologists are going to be absolutely vital. So basically, I think I've talked for quite long enough. Are you ready for the challenges? And thanks for listening. For my generation, it's largely over. We've done our bit. What we're trying to tell you is that the younger generation has an awful lot to do. In fact, basically, it's your job to save the world. Thank you very much. Thank you.
Thank you, Dr. Peter, for sharing your knowledge with us. It was a really, really nice presentation. If you have a couple of minutes, let's start a question and answer portion of the webinar. Remember to turn on your microphone if you want to talk to the speaker directly, or you can also write them on the chat. Many people is leaving because perhaps they have something else. But
I'm sorry, I went on a bit too long.
It's fine, perfect. So if anyone wants to, Edgar, if you want to speak out loud.
Yes, thank you for the presentation, Dr. Peter. Your concept of refinement of ingredients sounded like interesting to me because I'm working with insects and I don't know like if we should develop refineries for insect ingredients like at all, or should we just focus on having one ingredient or probably just processing in a one step to make it more easier and affordable, probably?
I think in principle, you should think about refining, because you never know what the value of your side chains are. There's, in any refinery, there's always a core product. Now, I presume your core product, basically from insects, is their high protein content. So it's primarily you are, if you're going to use them, break them down into ingredients at all, the primary thing that make the business work will be the protein. But there are all sorts of other interesting things I know which can be derived from insects. In many cases, you may find there are pharmaceuticals in your side chain which are really quite valuable. Never underestimate how much more doctors will pay for ingredients than people will pay for food. So it's wise. I wouldn't develop a factory yet, because I'd want to know I can even get my core cost major product right. But never ever underestimate the value of what your side chains might be. It may not even be in the food industry. It could be somewhere else completely. I mean, the famous case is, I'm sure everybody knows, you can't almost make a cosmetic now without put hyaluronic acid in it. And that was a waste product from the chicken industry when we first used it in Unilever. Coxcomb. Little did we know, you have to synthesize the stuff because there isn't enough around. But never, always look widely for the content of your side chains and the potential value, even if it's way outside the food chain. Yeah.
Thank you.
Any additional questions?
Yes. Hello, Peter. This is Uri. Yes. I like to ask a question.
Yeah.
That is because I'm involved in some task force looking at the concept of ultra processing.
Mm-hmm.
So I just wonder if you have any views on that concept that is spreading so much in the nutritional sciences and public health area.
Yeah. I mean, this is the most regrettable and unscientific argument I've ever seen. There is circumstantial evidence that suggests that people who eat more refined foods, which are the definition of ultra processed, health is in general lower. But the evidence that points to what the cause of that is so weak as to be negligible. And now, unfortunately, it's become a label for anything processed. And we have these incredible rules about clean labeling, where if I extract a polysaccharide, it's an E-numbered ingredient and may be considered ultra processed, whereas I wrap some rice in seaweed is perfectly natural. The problem, I think, is the lack of knowledge and understanding of how the supply chains work and what the materials are that we encounter and use throughout the food industry. I don't know how this is going to rumble on and on and on. I mean, you and I know, and we've argued about this with various protagonists for years. It's not going to go away. The industry is partly at fault by not explaining what it's been doing. So it's very easy to point to the labeling on a packet and say, would your grandma have used any of these ingredients? And grandma didn't use that word. So, this must be ultra processed or contains heavily refined materials. And this is nonsense. I mean, we can change the name if you like, and then it would have been something grandma recognized. I don't myself believe that processing has much to do with nutritional quality, except in the cases which I mentioned, where the process unfortunately removes or knocks out an available micronutrient normally present in an unprocessed raw material. Then you have to worry about it. I mean, if you had so much phytate that you've knocked all the iron out of a system, then of course you're going to influence a foodstuff, and that in turn will necessarily influence a diet. But the real problem about this, we have to educate our masters now, the consumers, to be more aware of the science of our materials and the science and engineering of the processes we must use if they are to survive and society at large is to be sustainable. To say that everybody needs to go back to using fresh materials and processed food themselves is impossible. And if we passed a law and that was done tomorrow, people would starve by the millions within a year. So that to simply say you shouldn't process food, let alone ultra process it, is clearly nonsense. And the arguments that say that some things are ultra processed is a matter of definition. I mean, how much processing is ultra? It's not well defined at all. So, but I think there is a responsibility from the industry and from legislators to educate the public on what they're eating, where it's come from, how we've processed it, and why. And I think if we do that openly, consumers are not stupid; they'll listen. I mean, I've given many talks to not unprofessional, relatively ordinary people who are not involved in science and technology, the food chain, and they're fascinated by it. They really want to know because it's part of their daily lives. So we have an opportunity to make it clear to them, but we have to be honest. So I think it's almost a conversation we've rehearsed before, Rio, but I still believe it.
I'd like to thank you very much because that's a very important issue and it's ongoing everywhere. And the nutrition is really, it's going to national guidelines in different countries, etc. So we have to really do something. And I fully agree every word you say.
I think in Brazil, it's now come out of the national guidelines, hasn't it? I think, has it not changed in Brazil? They were the first to promulgate it. And I think in Mexico, it's also been mentioned quite heavily, but I thought Brazil was taking a much more educated approach to the issue now, which is all to the good. And the one thing industry should not run away and hide. We've got nothing to be ashamed of. And if we can change, we will. So discussion, honest, open discussion is the best thing we can possibly do. Okay.
Thank you. Thank you, Dr. Peter. Perhaps one last question we have several questions, but just to keep on finishing, Rodolfo. Rodolfo, you have your hand raised.
Yeah.
I'm Sophie Rahman. I'd like to ask questions. Is it okay?
I think Rodolfo was before you.
Okay.
Go ahead.
Okay, thank you. I'm Sophie Rahman. I'm from Oman, close by Dubai, as you mentioned about the cheese. One thing, I think I missed a little part of your presentation. I'm working lots on the foods from waste.
Yes.
We have a lot of waste, skin, seed, lot, and as you say, some part of the world they eat some part they don't eat, and that should be shared. But don't you think we should have put huge emphasis on the foods from the waste? Foods from the waste, like it's foods from the skin, food from the seeds, food from the all waste should not go for the compost or fertilizer.
Yeah.
We can produce foods from the waste. That's my main area. But don't you think we should take this approach and also invest the new young food engineers and food scientists should emphasize on to produce that? Just to give you just your comments. Thank you.
Yes.
But thank you again for your nice presentations.
No, I agree entirely. This is a significant topic, and we have to discriminate actually between losses and waste. Losses are things that tend to happen in the field and the factory because of inefficiencies. Waste is largely at the end of the retail and consumer when the finished product is made and simply thrown away. Now, both need to be worked on, but they are different topics, because losses in the field or in the factory are usually of ingredients, rarely a finished product. Losses in retail and in the home are almost always finished product. The finished product is less easy to recover because it's complex. The losses in the field and in the factory are more easily contained. But you're right. It's a separate topic. Oh, hello. I've just been joined by my grandson. So I think the next generation is here. Okay.
Thank you so much, Dr. Peter. Well, you have some more questions, but I don't want to keep on attacking your agenda. So I will only want to thank you for this exciting topic. For this,
will you give my emails available?
For sure.
If people have questions that they'd like to address to me, I'm quite happy to receive them.
Let me just copy and paste the email here in the chat.
Offline or
Great.
online.
Thank you so much. And thank you so much, Dr. Peter, for this exciting talk. Hi.
Okay. Here's the next generation of food scientists.
Great. And
Thank you very much.
Thank you everybody for joining this webinar. We'll please keep on tuned on our Instagram account, Facebook page, LinkedIn for our March presentation, where we are going to have Oliver Schluter as speaker. Again, thank you so much, Dr. Peter. Nice meeting you, and thank you everybody. Bye-bye.
Okay. Thank you. Goodbye. Goodbye.